Right now, if you want to train a large AI model, there's essentially one company you're going to: NVIDIA. Google, Meta, Amazon. They've all been buying NVIDIA chips in enormous quantities. At peak demand, companies were waiting 6 to 12 months just to get access to them. That's the first problem. You can't build a business that depends on someone else's supply chain when that supply chain is this constrained. The second problem is cost. NVIDIA's H100 GPU, which was the go-to chip for AI training in 2023, runs about $30,000 per unit. To train something like GPT-4, you'd need tens of thousands of those. The bill gets large quickly. And then, once training is done, you still need chips to run the model every time a user sends a request. That cost never stops. So the motivation to build your own chip is pretty straightforward. Stop depending on one supplier and stop paying a premium for capability you don't fully need. Before getting into why companies are building custom chips, it helps to understand what the chip is actually doing. Training an AI model is fundamentally a math problem. You're adjusting millions or billions of numerical values called weights so that the model gets better at predicting outputs. Every step of training involves multiplying large matrices of numbers together, comparing the output to what the answer should be, and making small corrections throughout the network. Then you repeat that process billions of times. Running the model after it's trained, called inference, is similar. Every time you send a message to ChatGPT, the model is running matrix multiplications across billions of weights to generate each token of the response. When you buy an NVIDIA GPU, you're buying a chip designed to be good at many things. It handles graphics. It handles scientific computing. It handles AI. That flexibility is valuable if you're a research lab or a university running diverse workloads. But if you're Google, and all you're doing is running your own specific AI models at massive scale, that flexibility costs you. You're paying for hardware you're not using. Custom AI chips take the opposite approach. Instead of building a chip that can do everything, you build a chip that does exactly what your AI workloads need, and nothing else. That means more of the chip's area and power budget goes toward the operations that actually matter. The result is usually better performance per watt and lower cost per inference. Google has been doing this the longest. Their TPU, Tensor Processing Unit, has been in development since 2015 and is now on its 5th generation. Google built it because they were running inference on neural networks at a scale where even modest per-query savings compound into enormous cost reductions. Every time someone does a Google search, does a translation, or uses Google Photos, TPUs are running the models behind that. At Google's volume, small efficiency gains are worth hundreds of millions of dollars annually. Microsoft has been investing heavily in custom silicon as well, partly to support their Azure cloud business, and partly because of their deep integration with OpenAI. If you're going to offer GPT-4 to millions of users, the cost of inference chips is a critical part of whether that business makes money. Apple is the most mature custom chip builder of the group, though their motivation is slightly different. Their M-series chips power max and integrate GPU, CPU, and neural engine on one die with shared memory. The benefit for AI isn't just efficiency. It's that large models can be run locally on the device without a cloud connection. This is increasingly important as Apple builds more AI features directly into iOS and Mac OS. For companies that use AI as a feature rather than their core product, buying NVIDIA or renting from a cloud provider will remain the rational choice. The upfront cost and timeline for chip development makes it inaccessible for most businesses. The interesting longer-term shift is at the edge: phones, laptops, cars. As models get smaller and more efficient through techniques like distillation and quantization, running AI locally on custom silicon becomes practical. Apple is already here. Others are working toward it. The chip question is ultimately a cost question. Training costs are going down as models become more efficient. Inference costs are the ones that compound. Every user, every query, every day. That's where the custom chip investment pays off, and that's why everyone with enough volume is trying to build one.